This video is one of a series covering the released Ohio State math questions between 2017 and 2023. Welcome to Dr. Tarazi's math site. Statistics and probability is an important domain. 11 to 12 questions out of 48 are on the test. Investigate chance processes and develop, use, and evaluate probability models. Standard 7.SP.7. This is a very important standard. 3 to 4 questions out of 48 are on the test. Please pause the video and read the description of this standard.
Hello and welcome. Here is what you need to know before we get to the examples.
Mutually exclusive events.
If A and B are mutually exclusive, meaning they do not happen at the same time, then the probability of A or B is equal to the probability of A plus the probability of B. This is very important rule that we're going to be using shortly.
Recommendation.
To make the most of these videos, I suggest pausing the video when you see this button, solving the problem, and then resuming the video to check your answer.
Example 1.
A bag contains red, blue, yellow, green, and purple marbles, all of which are the same size. The probability of selecting a single marble for 2 of the colors is shown in the table. This is given, and this is given. The probability of selecting a red or yellow, see, the red or yellow, which do not happen at the same time, is 5/16, is given. The probability of selecting a green is twice the probability of selecting a yellow. What is the question? What is the probability of selecting a green marble? To find the probability of selecting a green marble, we need to find the probability of selecting a yellow marble, because the green marble is twice as much as a yellow marble. So let's see how we can set it up. Again, we're going to using this property, okay, because A and B, red or yellow, are mutually exclusive. They do not happen at the same time. Okay, so what we have given P red or yellow is 5/16. That's given. And also is giving P red is 2/16. So we have to subtract these two together to get the P yellow is 3/16. Because now 3/16, if you add it to 2/16, you get the 5/16. So now, since we know the yellow is 3/16, then we just multiply it by 2 to get the probability of selecting a green.
Example 2.
There are 30 students in Rakim's math class. The teacher randomly selects students one at a time to go to the board to complete a problem. The teacher selects each student once. Rakim is not selected for the first 5 problems. So 5 students have already been selected. What is the probability that Rakim is selected to go to the board next? So that's really very simple, because we have left 25 students to select from, and Rakim is one of them, say 1/25. So which is 0.04.
Example 3.
Kara's teacher divides her class of 20 students into 4 equally sized teams: the red, the yellow, the green, and the blue teams. So we have 4 colors. What is the probability that Kara is on the red team? So now don't be confused with this 20. It's not important. It's not going to play any role here. Here what we have is we have 4 colors, and what is the probability of selecting one color is 1/4. 1/4 is 0.25.
Example 4.
The 25 students in Jason's class have a choice of 3 extracurricular activities. Of the total numbers of students, 8 choose soccer, 6 choose math, and the rest choose chorus. What is the probability that Jason chooses chorus? Okay, let's put the information here. What we have: 8 soccer, 6 math. How many left from the 25? 11. Total 25. The question is, what is the probability that Jason chooses chorus? 11 out of the total. So 11 out of 25, 11 over 25 is 0.44.
Example 5.
This is a very interesting example. I actually like it. That's a three-part example. There are 23 students in Mr. Wilson's class. Mr. Wilson wants to determine the probabilities of male and female students playing on a school sports team. He surveyed his student and determined the following. So these are the information that we have. There are more males than females in Mr. Wilson's class. Okay. Fewer males than females in Mr. Wilson's class are on the sport team. The majority of females in Mr. Wilson's class are not on a school sports team. So let's see what we have here. So the first one here, we know that there are more males than females. So here you have to make a choice to put more males than females. And that's why when a second question here, it says complete the table to show possible values. Possible values meaning there will be more than one good answer, okay? So if I put 10 and 13, 13 and 10, that's fine. That satisfies this condition here, this information. You can put 12 and 11 if you want, so that would work too. Now, here it says the majority of females in Mr. Wilson's class are not on the school sport team. This is 10 total female. The majority, that means more than 5, that's 6. So you can put 6 here. You can put 7 if you want. 6. So now, since I have this information and this information, now easily I can find that this one will be 4 for sure. Good. Now it says fewer male than female in Mr. Wilson's class are on the school sport team. Fewer males. This should be less than this, okay? So you can choose maybe 3. And now we can fill up all the table. Now we have all the needed information. Here I will get what? 7. Now 23 minus 7, I can get here 16. 13 minus 3, I can get here 10. Now, part B, what is the exact probability that a female chosen at random plays on a school sport team? How many females do we have? 10. 4 would be on the school sport team, so that would be 4 over 10. C, what is the exact probability that a student chosen at random from Mr. Wilson's class is a male who does not play on the school sports team? We are selecting now 1 out of the 23, and it's a male who does not play, which is 10. 10 out of 23.
Example 6.
The letters tiles shown are placed in a ball. Matt selects one tile from the ball. Okay, what is the probability that Matt will select one of the letters in the word JUMP? Notice here they made it easy for you. Nothing is repeated here. Nothing is repeated here. So you have 10 here, you have 10 here, and then you have 4 options here. So that's 4 out of 10. Probability of J or U or M or P is 4 out of 10. That's 0.4.
Example 7.
A factory produces 80,000 candies each day. They produce equal quantities of 4 flavors: cherry, lemon, orange, strawberry. The candies are mixed together during packaging. What is the probability that a randomly selected candy is orange? Now again, this $80,000 has nothing to do with the answer, okay? It could be 200,000, it could be whatever a number it is. But you have now 1/4, you have 4 flavors, and you're selecting one of them, so 1 out of 4. That's very simple question like that. Don't miss on the test. 0.25.
Example 8.
A bag contains 25 cookies. There are 15 chocolate chip cookies, 7 peanut butter cookies, and the rest are oatmeal raisin cookies. 7, and that's the rest is all. What is the probability of randomly choosing a chocolate chip or peanut butter? See again the or. Okay, chocolate chip or peanut butter cookies from the bag. Of course, those two events are mutually exclusive. You can't select one that has the same flavor. Okay, so now what we have, let's put this together here. So we have 15 chocolate, we have 7 peanut butter, and we have 3 oatmeal. What is the question is chocolate or peanut butter? Chocolate or, that's 22 out of 25. 22 divided by 25, 0.88. If you want to have chocolate is 15 over 25. To have peanut butter is 7 out of 25. And since these two are mutually exclusive, then you just add these two numbers. Okay?
Example 9.
Zain has a bag filled with coins. The bag contains 7 quarters, 8 dimes, 3 nickels, and 9 pennies. He randomly chooses a coin from the bag. What is the probability that Zain chooses a quarter? Again, a quarter or nickel. Quarter or nickel. This doesn't happen at the same time, so these are mutually exclusive events. So let's put the information here: 7 quarters, 8 dimes, 3 nickels, and 9 pennies. Total, make sure it's 27. Chooses what? Quarter or nickel? Quarter or nickel. That's what? 7 plus 3 is 10 out of 27. 10 divided by 27.
Example 10.
A gumball machine contains equal numbers of red, yellow, green, and blue gumballs. If it randomly gives out one gumball for each pull at the machine, what is the probability of getting a red or green again? Red or green gumball from one pull at the machine. Again, these are mutually exclusive events. They don't happen at the same time. So what do we have? We have red, yellow, green, and blue. That's 4. So to get red, that's 1 out of 4. To get green, that's 1 out of 4, and you add them, okay? It's 2 out of 4. Because you have red or green, that's 2 favorite options out of 4. That's 1/2.
Example 11.
Mr. Larkin grouped his students in his class into 4 groups of equal size, labeled red, blue, green, and yellow. Each day, Mr. Larkin selects one group at random to read aloud during class. The groups selected during each day for 8 days are given here. Okay? Which group's observed frequency of being selected is closest to the expected frequency? Now, let's see. You have here green is 2. 2 out of 8. Blue, 1, 2, 3, 4, 5. 5 out of 8 blue. And that one is green. And red is 1 out of 8. Now, since you have 4 colors, so you have a 25% chance to get any one of these colors. So if you're looking at here, you have that's 1/4. This is much more than the expected frequency. That's less than the expected frequency. This one is equal to 1 over 4, and that's what is the expected frequency because we have 4 colors and we are picking up 1 out of the 4. Okay, so the answer will be green, group green, 2 out of 8, 1 out of 4.
Thank you and see you soon.
Thank you for watching. More videos to come. Please subscribe.